let's start applying the laws of logarithms. What can we apply them to? Surprisingly, measuring earthquakes, measuring sound intensity, and wow, the acid-base scale in chemistry. Ho, 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 ho. Cool. All of these are based on logarithmic functions. Okay? I'm going to do each one of these in a separate podcast. So we're going to start with earthquakes. Earthquakes, if you've never heard about an earthquake or listened to the news, you got to realize that an earthquake is actually measured on something called the Richter scale. And the formula for the Richter scale is down right here, because they'll say the magnitude earthquake of 5.7 rocked such and such country and created this kind of damage. Well, the Richter scale then measures the intensity of the earthquake, and it's a tenfold increase. So as soon as you start thinking tenfold, I think of log base tens. Yeah, and here's the formula for it. Now, I'm not going to make you memorize that formula, and every time I see a question like this on an exam, they always throw the formula at you. So there's no big scariness that you have to memorize this. But think about this. This is basically the intensity of the earthquake divided by a reference. You take the log of it, you get something called the magnitude. Huh? Wait a second. What does this mean? Well, basically, how much are you shaking compared to what we call a reference where you're not shaking at all, and you take the log of this and you get that magnitude 5, magnitude 7, magnitude 9, good God, I hope not, earthquake, okay? And every time you start talking 5, 7, 9, you're going up with each number up by a factor of, 10. Aha, okay. So how do we go about doing questions with this? Really simple. The best thing that you're going to actually do is start comparing the earthquake intensities. And that's really, really cool, because what you're going to do is you're going to take one earthquake, let's say that happened in some country, okay, compare it to another earthquake and tell me in terms of how many times is this one stronger than the other one. So basically, all you have to do is you're comparing the intensity of one earthquake, comparing the intensity of the other one. But the nice thing about logarithms is you remember that because this is a base 10 and this is division, all you have to do is subtract. Oh, and that's what I got here. Base of 10, subtract one intensity or one magnitude, subtract the other magnitude, and you've got the answer. Boy, this is going to be easy. Check this out. On we go. Let me show you how this works. I got two questions for you, real pretty ones happening right now. It says, compare the two earthquakes that hit the country of Chile. How many times more intense was the 1960 earthquake, which is a magnitude of 9.5, compared to the 2005 earthquake, which was a magnitude of 7.8? All you got to do is go power of 10, subtract them, and you got your answer. It's that simple. If you do that, you got power of 10, 9.5 minus 7.8 works out to be 1.7. Go into your calculator, hit 10 to the power of 1.7, and you find out that this is 50 times stronger. That's it. Boy, that's got to be the easiest question I think we've done all year. Huh. On we go. Look at number 2. It says a major earthquake of magnitude 7.5 is 375 times as intense as a minor earthquake. Find the magnitude to the nearest tenth of the minor earthquake. Oh, well, simple. If you think about this, there's that 10. You take one earthquake, subtract the magnitude of the second earthquake, and it gives you, how many times more powerful it is. Well, it tells you that this one's 375 times more powerful. So there we go, 375 times more powerful. Put it there. Now, magnitude 7.5. Okay, there's my 7.5 compared to a weaker one. The whole question is, find me M2. Okay, how do we go about doing that? Well, it's actually pretty easy. The way we do this is very, very straightforward. I'll show you. You're going to use logarithms. Remember how logarithm works. This is a logarithm of base 10. So you're going to go log base 10 of 375. And that's going to equal to, guess what? It's going to equal to 7.5 minus M2. Oh, that was easy enough to do, isn't it? Yeah, that's it. That's how you do it. Very straightforward. You got to know your log loss. Okay, so what is the intensity of the M2 earthquake? Well, then M2 then, bringing all of this over to the other side and subtracting and everything else, is 7.5 minus the log base 10 of 375. All I did was just straight out algebra, remembering that this is just a number. Okay? Straight out algebra. That's all I did. And if you did that and you punched it into your calculator, you ended up getting 4.9. So there's a minor earthquake, there's a major earthquake. There you go. Now you can see that the difference between them is 375 times. Not a very difficult thing to do. Basically, you're looking at just subtracting the exponents, putting it to the factor or to the power of 10, or using a common logarithm of base 10. You got the answer.